we are looking at how we can use the Gaussian eliminations to solve simultaneous equations. So this is simultaneous equation in two variables. After this, in our next class, we will do the simultaneous equation in three variables using the Gaussian elimination method. So in using the Gaussian elimination method in solving simultaneous equation, this is how you are going to do it. You are going to take only the coefficients. So let's write our solutions here. So the coefficient here, we have 3, and then here is what? -1. Then here we have 2, and here we have what? 3. Now we have to write our argumentative matrix. So you bring a bar here and write your 7 and what? 12 over here. So this becomes the argumentative matrix. Now we have to make this place to be 0. We have to make sure this place is what? 0. So this is what you are going to do. You are going to form your own formula. You are going to form your own formula that will make this place to be what? 0. So this is my row 1 and this is my what? Row 2. So let's row 1 and what? Row 2. So to make this place to be 0, let's see what you can do. It is on row 2. So let's change that. It's equal to, so if I multiply this row 2 by 3, so let me write it row 2, then I subtract it from 2 times the row 1 over here. I am going to get this place to be 0. So let's check something. So now we are going to get it to be 3 times the row 2 here, so 2, minus 2 times the row 1 here, that is what? 3. So 3 will give us 6 over here. Then 2 minus 3 will give you what? 6. That will give you 0. So now our row 2 over here is what? 0. So now let's draw it here. So we maintain the first row, that is 3 and -1, then 7. So now we have here to be what? 0. So first we have changed this one. We have to change whatever that is here, all the rows over here. So we are using the same formula, this same formula, to change everything that is here. So let's draw this. So using the same formula, that is R2 is equal to 3 R2 minus 2 R1. Now our row 2, this side will be 3 times, then we come to this one, 3 times 3 minus 2 times the row 1, that is negative, the -1 over here. So we are going to get a 3 will give us 9. -2 times 1 will give you what? +2. So now the row 2 over there is going to be 9 plus 2. That will give us 11. So now we have this place to be what? 11. So 11 this side. Let's change this one too, using the same formula. So using the same formula, R2 is going to be 3 times the 12, 3 times 12 minus 2 times 7, 2 times 7 over here. Now 3 times 12 is going to give us what? 36, minus 2 times 7 is what? 14. So 36 minus 14 will give us 22. So we come here and write our 22 over here. Now our work is done. Let's solve for, we know that all this side is x and all this side is what? Y. The x place here is what? 0. X place here is what? 0 over here. Now we can equate 11y is equal to the 22 over here. Now we can solve for our y, dividing through by 11. So our y is going to be 2. Y is equal to 2 over here. Now let's go and set this equation. We have x placed to be 3. So we have 3x minus 1y, or we can just write y is equal to the 7 over here. So 3x minus the y, we got 2. is equal to 7. So now 3x will be equal to 7 plus 2. 3x will be equal to 7 plus 2 give us 9. Let's divide through by the 3. So now our x is going to be 9 divided by 3 will give us 3. So now the value of x is equal to 3 and y is equal to what? 2. So using the Gaussian's elimination, this is our final answer for the simultaneous equations. That's very simple way of also solving simultaneous equations. Follow and let's learn more about this Gaussian's elimination.